In 340 BC, Aristotle wrote in his book On the Heavens that Earth is not a flat plate. It's in fact a spherical ball around which the Sun and a bunch of other planets revolved around. He argued that Earth was the center of the universe. And in 180, Ptolemy popularizes this model of geocentrism. He argues that the Earth is in the center of the universe and we are surrounded by stars and the Sun, the Moon, and the 5 planets closest to us. And all of these planets are moving in a complicated pattern around us. Ptolemy's model was adopted by the Catholic Church, and that became the layout of the universe according to the scriptures. And in 1514, a Polish priest publishes a book. And in this book, he writes about how the planets don't move around in complex orbits around us, but rather all the planets move around our home star, the Sun. We orbit the Sun. We are not in fact the center of the universe. This man's name was Nicholas Copernicus. In 1609, 2 men by the name of Galileo Galilei and Johannes Kepler, with the help of the invention of the telescope, brought about the death of Aristotelian Ptolemaic model, or theory in fact. So Galileo observed through his telescope that the moons of Jupiter were orbiting this gassy planet. I mean, that was not supposed to happen. They were supposed to be orbiting around us according to the Aristotelian Ptolemaic model. So he postulated that everything did not have to revolve around us. And around the same time, Kepler comes out and adds to this theory of Galileo. He states that the path that the planets orbit in are not in fact orbits, they're ellipticals. This progression of our understanding of the universe from a geocentric model to a heliocentric model brought about everything that we understand about the universe today. It paved the path for Newtonian physics and eventually Einstein to show up and give us general relativity. But why was the heliocentric model preferred over the geocentric model? That's because through our understanding of the geocentric model, we could not account for all the complicated ellipses that the other planets and the Sun took. I mean, the Sun was pretty well understood, but the other planets not so much, especially when they progress further away from the Earth. And obviously the heliocentric model comes around and everything that we see about the universe and observe about the universe suddenly is a little simpler and well explained. This is the Occam's razor in action. So what is Occam's razor? Occam's razor is a philosophical / critical thinking tool that people use for simplicity in the pursuit of the truth. It was popularized by a friar and a philosopher by the name of William of Occam in the 14th century. So again, what is Occam's razor? So Occam's razor states that the simplest explanation is preferred to one that is more complex. Simpler theories are easier to verify and simpler solutions are easier to execute. In other words, if you have two competing theories and they both explain a phenomenon, but one explains it simpler without additional assumptions and presuppositions, that one should be preferred to the more complex one. Or in the words of our brown parents, you eat your food this way, not around your head. So in the natural sciences, the reason why Occam's razor is so preferred is because nature functions in the simplest way possible. Nature is a machine of simplicity. So if it can complete a process through one factor, nature is not going to add an additional factor for absolutely no reason. And Occam's razor ties very neatly with the idea of falsification. Falsification was an idea proposed by Karl Popper, a very important scientific thinker from the 20th century. And he suggested falsification. So falsification is basically, for a scientific theory to be true, it needs to be falsifiable. It needs to be able to be proven wrong. If you cannot prove a theory wrong, it does not have any validity when it comes to scientific theory. Only if a theory can be proven wrong, then it can be a scientific theory. So if you claim the existence of an omnipotent being and you cannot actively test it, you cannot run experiments that produce repeatable outcomes, it does not really count as a scientific theory. So hypothesizing about things that cannot be felt, seen, repeatedly tested and measured generally is avoided in the circles of scientific thinking. So Occam's razor is often used in the field of medicine because doctors have to account for a lot of symptoms and then chalk it up to a set disease that accounts for most, if not all, of the symptoms. And there's this, there are multiple sayings from the field of medicine. So one of them is common things are in fact common. That basically states that, let's say a patient walks into your clinic and the patient has flu-like symptoms. The probability of the patient having flu is way higher than, say, this normal disease that shows flu-like symptoms but also is fatal. And there are other analogies that are very widespread in the field of medicine as well. For example, one would be, let's say you walk into a building and on the outside you hear hoofbeats. You can hear hoofs running around and all of that, right? You would be right most of the time to assume that it's horses and not zebras, or say, least of all, unicorns. So the famous saying is, when you hear hoofbeats, think horses, not zebras. So such simplifications help doctors treat their patients of the symptoms they are indicative of having, rather than, say, some other disease that they could overtreat them for. And obviously, you wouldn't be completely wrong if you had to, say, question the validity of Occam's razor in a lot of situations. This is not a foolproof law. It is just a tool in your toolbox, in your critical thinking toolbox, to help you make better decisions and come to better conclusions. And obviously, a theory or a conclusion cannot be picked just because it's simple. It needs to be backed up with enough empirical evidence to support the theory or the conclusion. So Albert Einstein explains this pretty well in his own words, or paraphrased words. He says, everything must be as simple as possible, but not any simpler. Or, to add to the aphorism, when you hear hoofbeats, think horses, not zebras, unless you're in the African savannas. Thank you for watching. Again, if you enjoyed this video, give it a like, share it to anyone you think would enjoy this sort of a video. There's nothing else to say. I'll see you tomorrow. Bye-bye.